we're going to talk about factoring polynomials. So we did factor quadratics a lot in chapter 2. So we're going to talk about how do you factor these bigger polynomials, these things with x to the thirds, x to the fourths, and those kind of things. If you remember, when we were factoring quadratics back in chapter 2, we had a situation where instead of just saying like x squared, it would say like 2x squared or 3x squared or 4x squared. There'd be a number other than 1. We had to do that long factoring. We had to do like a times c, and your b is your middle term. We had to rewrite kind of the polynomial so that we could then group together our terms to factor it. And we were looking for the pieces like inside the parentheses to match. Okay, we did that probably towards the beginning of chapter 2 when we first started talking about factoring. So we actually use some of those same methods when you're trying to factor big polynomials. When you've got things that have large exponents, so to the third power, to the fourth power, and so on, so more than just an x squared or whatever the letter might be, and you've got more than 3 terms, so it's no longer a trinomial, you've got 4 terms, or however many they want to throw at you, we can still factor them by grouping them together. So for example, if this is what they give you, 21 n to the third minus 7n squared minus 9n plus 3. This has 4 terms, so if you're trying to factor it by grouping, you want to cut it in half so that it's like evenly grouped. 2 in one set and 2 in another set. And so I just put parentheses around those. I put parentheses around the first 2 terms, parentheses around the second 2 terms. And on the second 2, because it says -9, I make sure to pull the negative in to the parentheses, because I'm probably going to want to pull it out eventually. And then if you think about when you guys were grouping, back when you were factoring quadratics, you were looking for anything that you could take out. Do they have any numbers in common? Do they have any letters in common? So for 21 and the 7, I can take a 7 out of both of those. The first one has n to the third, and the second one has n squared. So we can take out an n squared. So what's left then from the first set is you have 21 divided by 7 would leave you with 3. If I have n to the third and I took away 2 of them, then I'm left with just an n. And from the next piece, I took away the 7 and I took away the n squared. That doesn't make it a 0 though. That makes it a 1. Remember, anything divided by itself is 1. So we're going to have 3n minus 1 left. So remember when we were factoring before, what's inside the parentheses there, we want it to match on the other side too. So when I factor this second grouping, I want there to be 3n minus 1 left in my parentheses. So if it helps you, I would almost just go over here and write that out. And then ask yourself, what did I take out in order for there to be a 3n minus 1 left? Now notice that the sign switched. Like originally, it says -9n plus 3, and what's left is positive 3n minus 1. So I took out a negative number. Okay, so I know I took out something negative because I had to get those signs to switch. What's the number that I took out? 3. So I took out -3 in order for that to become 3n minus 1. Okay, so the insides of those parentheses match. So then if you don't remember, what you do to kind of finish this up is the pieces that are sitting outside or out front of the parentheses, so the 7n squared and the -3, that goes in its own set. And then the 3n minus 1, you just write that down one time, and that again goes in its own set. And so this is the factored form. Okay, let's work through another one here together. So we have 40 m to the third minus 15m squared plus 56m minus 21. So again, we've got 4 terms. We're going to go ahead and just group the first 2 and group the second 2. So 40, 15. What's a number that can go into both, that I could like divide them both by? 5. How many m's can I take out? 2, because the first one has m to the third, the second one has m squared. So I should be able to take out m squared. Okay, let's talk about what's left. So 40 divided by 5 would be what? Good, 8, and then you're left with an m, because we had m to the third, and we took away 2 of them. What's going to be left from the minus 15m squared? Good, negative 3. Okay, so again, remember over here I want 8m minus 3 to show up again when I pull out something. So in this one, I didn't take out the m at all because the m stayed. It says 56m and I still see 8m, so I'm only taking out a number here. What number could I take out of both 56 and 21? 7, and it's positive, so plus 7, and that leaves me with that 8m minus 3. Okay, so 8m minus 3, those match. 5m squared and the plus 7, those are going to get paired up together. So 5m squared plus 7 goes in one set of parentheses, and then 8m minus 3 goes in the other set. Do you have questions so far on how I got any of those numbers? I want you guys to try that third one on that page by yourself. Group it, and then try to factor it. Okay, so we group the first two terms, 35b to the third, 28b squared. Then I would take negative 25b and the negative 20 and group those into the second set. What did you guys take out of the first set? Good, 7b squared, so what was left? Good, 5b plus 4. So I want 5b plus 4 to show up again. What number did you have to take out? Good, negative 5. And remember, we talked about this when we were factoring quadratics, that if you see those signs changing, so it's a negative, negative, and I want it to become a positive, positive, that kind of always just told you you're going to have to take out a negative. I would say about 9 times out of 10, when you see a negative in that second grouping, you're probably going to want to take it out. You're going to want to factor out the negative number instead of a positive. Okay? It happens sometimes that you don't, but it's really rare. Most of the time, you're taking out the negative. Okay, so then final answer should have said 7b squared minus 5, and then 5b plus 4. All right, so what I also want to talk about with you guys today is some special cases when it comes to factoring. And these are called the sum or the difference of two cubes. Cubes is when you raise something to the third power. So like a to the third power, 5 to the third power, or a number or any other letter out there. Sum is when you add them. Difference is when you're subtracting them. So when we talk about the sum or difference of two cubes here, we're talking about two separate quantities that are both raised to the third power, and you're either adding them or you're subtracting them. When you have cases like this, they have special rules that you can follow to factor them. And they both, I've got them written out here for you. Okay, and so for the sum, you do your a plus your b, and so that would just be the letter that they're using or the number that's raised to the third power. And then it says a squared minus your a times your b term plus your b squared. The difference factored form looks a lot like the sum, except some of your signs have changed. Okay, notice how it started a plus b and it becomes a minus b for the difference. And in the sum, this one was negative, and in the second one, it's positive. So there's just a couple of sign changes that happen with them, but they're really similar in kind of how they work. Now, when you guys see A's and B's up here, like I told you, A and B are kind of the generic form. A could be X, it could be a number, and so could B. B could be Y, or it could be another number. They don't have to necessarily be an A and a B. They can be letters, or other numbers. What's important and kind of like the key thing here is to be able to identify, like, what is the A and what is the B. Okay, because once you know what those two terms are, you can put it in one of these rules. So let me show you how you find what the A and what the B are for your problems. So for this first one, it says 216 plus 125x to the third power. So I don't have A's and B's. So we got to figure out, like, what is the A and what's the B term. What I want to do is look at those numbers, 216 and 125. If you have a calculator in front of you, and if you don't, you might want to get one out, because I'm going to show you how to take the cube root of something, because you're trying to figure out what number to the third power got me to 216 or got me to 125. Okay? Now, most of our calculators have a square root button programmed in. Okay? Now, a cube root button looks like a square root button, but it has a little teeny tiny 3 in the corner. Okay? So it looks something like this. Now, some calculators have a button like that programmed in. I don't think mine does, but some do. Now, if yours doesn't, there's probably a button somewhere that you can either use, or there's one that looks like this. It's got like a little X up in the corner. So I'm trying to see. Some of you, like with your calculator, you probably have the X key, and it's probably close to your square root button, is my guess. On the yellow ones, where's it at? Okay. So some of you might have to hit your second key to get it to actually function. But when you have, whether you have like the cube root one, if that one's programmed in, you can go ahead and use that. But if you don't, if you just have the X one, here's how you need to type it into your calculator. Since we're trying to find the cube root, you put a 3 first. Okay? And then you hit your button to get that square root sign with the little X up in the corner. And then you type in your number. So we're going to type in 216. So it's going to look a little funny when you enter it, but that's how you want to type that in. And then you're going to hit enter. And a number should pop out. Anyone have the number? 6. Okay? So this equals 6. So here's what that means. 6 to the third power is how I got 216. So right now I'm going to rewrite these as terms to the third power. Now let's do the same thing with the 125. So let's find, again, the third, or the cube root of 125. And what do you get? 5. Okay, so 125 is the same thing as 5 to the third power. Okay, now on the second term, because it also has an x to the third, here's what I'm going to do. I'm going to put the 6 in parentheses and then raise it to the third power. Plus, then I'm going to put 5x and raise that to the third power. All I'm doing right now is I'm rewriting it because I want you guys to be able to see what's in the A position and what's in the B position. So for this problem, 6 is your A and 5x is your B. Okay, and I'm talking about A and B back up from my rules. Now this one has a plus sign, which means that we're using the sum rule right now. Now that you know what your A and your B are, it's a little bit easier to write out the rule because I'm going to put in anywhere up in that rule where you guys see the letter A, I'm going to put in the number 6. Anywhere where you guys see the letter B, I'm going to put in a 5x. You guys following me? So I'm going to just take those terms, 6, because that was 6 to the third to get to 216, and 5x, because that got me 125x to the third. I'm going to replace A and B with those terms now. So it says A plus B, so that's going to be 6 plus 5x. That goes in the first set of parentheses. Then it says A squared, so that's going to be 6 squared. Minus, then it says A times B, so that's going to be 6 times 5x. And then it says plus B squared, so plus 5x squared. The last thing that I do here is I try to simplify like this big portion because I don't like it to say 6 squared or have like a bunch of parentheses. I want to try to simplify it so that it's just a more fluid sentence there. So I'm going to write 6 plus 5x. There's nothing I can do with that first piece. We leave that alone. What's 6 squared? 36. What's going to be 6 times 5x? Good, so negative or minus 30x. And then with this 5x, since you're squaring it, you have to square the 5 and you have to square the x. So what's 5 squared? 25 and then x squared. This right here is going to be your final answer. This is its factored form. Okay, the biggest piece kind of to the puzzle here is to figure out what's A and what's B. Because once you know what those terms are, it's just following the rule up above and plugging in to the right spots. Okay, so let's take a look at the second one here. I've got 250 A to the third plus 54B to the third. Now, if you guys have calculators in front of you and you're trying to take the third root of 250, you don't get a nice number. Okay, you get 6.299605249. And it would keep going, but that's all my calculator is going to show me. If I do the third root of 54, the same thing happens. I get another not great number. I get 3.77976315. Okay, so what does that tell us? Right now, these numbers are not perfect cubes. So I'm going to try to take something out to get them to be perfect cubes. Okay, so in the past, we talked about perfect squares. I wrote that list of numbers down a couple times for you guys, like 9, 16, 25, 36. Those are your numbers squared. It might be helpful for you to kind of try to remember some numbers that are raised to the third power. And if you don't remember them, you always have a calculator, so you can always do something to the third power. What I'm going to do on this one is actually take a 2 out of both of these numbers. So I'm going to divide the numbers by 2. So it's going to now say, a 2 is going to like sit up front. Like I'm factoring out a 2 basically. 250 divided by 2 is 125. A to the third. And 54, if I factor out a 2, is 27. And that's going to be B to the third. Okay, so because I took out this 2 that factored out 2 is just going to kind of tag along on this entire problem. Okay, it's just going to kind of stick in the front. Don't forget about it, but it's not really going to do anything to my problem. I'm just going to have it just attach. So now let's take a look at the 125 a to the third and the 27b to the third. Now let's try to do our cube roots of 125, which we did 125 earlier. That was in that first problem. What did we say 125 was? 5. So I'm going to rewrite this as 5a to the third. What's the cube root of 27? 3. So 3, and then I'm going to write b to the third. So the 5a piece, that is your a portion, and the 3b is your b portion from the sentence up above, that rule. So if you look back up at your rule, this is still a sum problem. It still has a plus sign in the middle. Again, I said that first 2 here is going to have to just tag along. So put 2 out front right away. So it says a plus b. So what would you guys write? What's your a and your b term? Good. 5a plus 3b. Okay, then we have to do a squared. So a is 5a. So what would be the 5 and the a squared? What would be 5 squared? 25. And then a squared is just going to attach. Then it says minus your a times your b. So what is 5a times 3b? $15ab. Good. Okay, and then last is plus your b term squared. So that's the 3b squared. So what's 3 squared and what would be b squared? 9. And then just b squared. Right, so all that cube root is showing you is it's how the rules say a to the third, b to the third. This is showing you those quantities to the third power so that you can see this is my a portion and this is my b portion. It gets a little confusing when they actually use a's and b's, okay, because then it's like, well, which is which. So that's why I really try to emphasize like putting those pieces in parentheses so that you can see the whole quantity. Like I said, I think that's going to be probably the biggest thing that you guys have to get used to is understanding how to rewrite the terms so you can actually find your A and your B. Okay, let's do one more here together. This is the last one. So I've got 3x to the third minus 81y to the third. So again, if we try to do the cube roots, like if you try to think, what's a number to the third power? What's a number times itself 3 times that would get me a 3? Nothing. There isn't one. Okay? So instead, because 3 is such a small number, and I need to try to take something out, like the last time I took out a 2, let's see what happens if we just take out that 3. So if I factor out a 3 out front, I'm left with x to the third. What would be 81 divided by 3? Good. So 27y to the third. Okay, so let's figure out what the a and the b terms would be. Now this one has a minus sign, so we're actually going to use the difference rule from up above. Now 3 is still going to have to stay out front. Again, that one's just going to kind of tag along on this whole problem. Now x to the third, that one's kind of already done for us. Like, we don't have to do a lot of work with that one. But I do need to figure out what the cube root of 27 is. So if you have a calculator, find the cube root, or think to yourself, what number times itself 3 times would get me 27? 3. So I'm going to rewrite this as 3y to the third. So from here, which piece is actually in like the A position? X is in the A, and which piece is in the B? Good. Just 3y. So don't worry about the sign, because the signs are taken care of for us in the rule. Okay? So the rule, now we're using, like I said, because it's got a minus sign up here, we're using the difference rule, so the second one. So that one starts with A minus B. So what would you guys write there? Good. And let's make sure we have our 3 sitting out front too. We can't forget about that piece that we factored out. So x minus 3y. Okay, then it says a squared. So what would that be? Good. X squared, because x is my a for this problem. Then it says plus. So I'm reading from the rule there at the top of that page. Whoops. So plus a times, or x times 3y. I'm just going to finish this up really quick for you guys. And then plus b squared would be your 3y squared. So that would be 9y squared. Really quick on the next page, guys, is the assignment. I only want you to do the odds, but you can cross off a couple problems. You can cross off 17 and 19, 23 and 25. You can cross those problems off.